Welcome to part 2 of our Ellipse series on conic sections. In this video we're going to take a look at 2 examples, and I'm also going to actually let you work on some problems on your own. I'll present to you 4 exercises. I'm not going to go through them, but I'll let you pause, work on them, and then when you press play I'll have the answers up on the screen for you. So here we go, number 3. This is a continuation of our part 1 video, of course, and our job here is to graph the ellipse seen here. This is kind of a strange looking ellipse. It doesn't really look like much of what we remember our ellipse equation to look like. Our ellipse equation looks like this, or at least something like this, where you have like a big fraction plus a big fraction, and that is equal to 1. Sometimes the a and the b can be switched around. Sometimes the x can be by itself, sometimes the y can be by itself, and sometimes both of them can be by themselves. But if you look at this thing, it doesn't look anything like that. So our job is to get this equation into this format somehow. And to do that, we are going to use our skill, our Algebra 2 skill of completing the square. In this case, we're going to do it twice. Completing the square twice. So we're going to group these terms by their variables. So let's rearrange the equation so the x's are together and the y's are together, and the numbers, the constant's just kind of right there. Some people like to put the constant on the other side. It doesn't really matter. As long as it gets over there at the end, or by the end, you're fine. So here's what we want to do. We want to take and work with the x's separately from the y's. So we're going to complete the square with the x's, which means we want to go x squared plus 6x, leave us a blank spot, plus we're going to take the factor, the greatest common factor out of 4y squared and 8y, which is going to be 4. I shouldn't say greatest common factor, just the greatest common factor of the coefficients. You're not going to take a y out. We're going to leave y squared minus 2y, leave a blank spot, plus 9, leave a couple blank spots, equals 0. So if you remember, we've done this in our parabola video. We did it in Algebra 2, of course. But we're going to basically just divide that 6 in half. You get 3, and then you're going to take 3 and you're going to square it. And that number gets added right here. If you add a plus 9, if you add a 9 to the left side of our equal sign, you want to subtract a 9 from the left side of the equal sign to preserve the value of that whole left-hand expression. Same thing here. We're going to divide -2 in half, which is -1, and then we're going to square that, which is +1. We're going to add that right there. Now a lot of students tend to think that since we added 1 here, we want to subtract 1 here, but that's not right. It's not right because, think about it, it's not actually 1, it's a 4 times a 1. 4 times 1 is +4, so we want to subtract 4 to preserve the value, preserve that equality there. Alright, so that was completing the square twice. Let me get rid of some of this stuff and we'll continue working here. We've got this thing is x plus 3 quantity squared plus 4 times the quantity y minus 1 squared, plus 9 minus 9 is 0, minus 4 equals 0. So let's move that minus 4 over to the other side. Alright, so now we're getting closer to what our regular ellipse format looks like. Next thing you want to do here is always, if you have a number here, get that to be 1. So we're going to divide everything by 4. When you divide everything by 4, you're left with quantity x plus 3 squared over 4 plus these cancel out over, that's actually just y minus 1 over 1 is equal to 1. Alright, so we have our, that's kind of like our nice format, that's our standard form of the ellipse, and from there we can start pulling out our center, our we can talk about our major axis, which way our major axis is facing, either horizontal or vertical. And we can also get our A value, our B value, and our C value. Remember, your relationship between A, B, and C from our first video is that C squared is equal to A squared minus B squared. Alright, so here we go. Let's first talk about our center. Our center is -3, +1. And I'm getting those from these sort of binomials here. If it's +3, your center is -3. If it's -1, your center is +1. The A value is always the bigger of the two denominators, so that's going to be, that's actually A squared. If A squared is equal to 4, obviously A is equal to 2, which means that this down here is B squared is equal to 1, so B is equal to 1. And to find C, of course, we're just going to simply plug that in. 2 squared is 4 minus 1 squared, so C squared is equal to 3. C is equal to radical 3. Cool. And remember, the C value sort of tells you the distance that your focus, or your foci, excuse me, are from the center. All right. Next up, the major axis. Is it going to be situated up, or is it going to be situated left and right? So up and down, or left and right? And to answer that question, you basically just want to look at where your A variable is. If your A variable is underneath your X term, X should tell you that we're going horizontal. So that means that our ellipse is going to be sort of stretched out horizontally like this. Alright, let's start to graph some of this stuff, and we'll see if we can make some sense of everything. -3, +1 is our center. I'll put that right there. I'll put that in red. I'll label it point C. Well, I won't label it point C. I'll just leave it like that. And from there, I know my major axis is horizontal, so 2 by definition is the sort of the half of the major axis. In other words, the major axis is 2A, which is 4. So that means that from the center to the vertex, I'll put the vertex in, I don't know, like a dark green, is 2 units. So it's 2 units left, 2 units right from the center. And that is called, those dark green points are called our vertices. Each one is a vertex, plural is vertices. And the vertices are the endpoints of the major axis. Alright, let's do the minor axis next. I'll put the minor axis in brown. The minor axis is twice as long as B. In other words, B is half of the minor axis. Sometimes you'll hear it read as 1 is the semi-minor axis or something like that. But in any event, from the center we're going to go up 1 and we're going to go down 1. And I put our dots. Remember, the minor axis is always perpendicular to the major axis. And the only other thing we need are the foci. The foci, I'm going to zoom in on this a little bit. The foci, if you remember, are always C units away from our center. So the foci in this case, and I'll put the foci in purple, are radical 3 units away, and the foci are always on the major axis, so they're always going to be straight in line with the center and with the vertices. Before I continue, I think it's worth mentioning here some new terminology. I don't think I mentioned these words, these terms in the first video. These are called our co-vertices. So one of them is called a co-vertex. Co-vertex, and this one is another co-vertex. These are the endpoints of the minor axis. Alright, so back to the foci. We're going to put them in purple, and they are going to be radical 3 units away from the center. Radical 3 units is, I think it's about I don't know, 1.7 or so, something like that. So I'm going to go from here, I'm going to go 1.7, so it looks like it's going to be right in here somewhere. That's our focus. And left about 1.7, and that's our focus. So we have our center in red, our vertices in dark green, our co-vertices in brown, and our foci in purple. So now we are ready, of course, to connect the dots. Let's see if we can't connect these dots and make a nice ellipse. And that's not too bad. I also figured something out. I figured that if I click on that, I can change the shape to an ellipse, and it kind of fits a little bit nicer. I can, if I want to, I can sort of select it. Well, maybe not, but yeah, I can select it and sort of squeeze it in a little bit to make it fit really nicely, and it looks a little bit better than my first video did. Something like that. Okay, so there is example 3. Let's move on to the next example here. Example 4. Example 4, we're going to analyze the ellipse, and what that means is find the center, the vertices, the foci, and graph this thing. So let's do this. If you want to pause it and give it a shot, you can. If not, that's okay too. Like I said, I'm going to follow this example up with a few other points and then allow you to actually practice 4 on your own. So here we go. We're going to group these terms by their variable, the x's together, the y together, and the constant sort of over here on its own. And I'll leave a little bit of space here for what we need to add to preserve our equality. So the 4 and the 8, well, we're probably going to take a 4 out of there, so let me do that now. I'm going to take a 4 out of here. If I take a 4 out of there, it becomes just 1x squared, and that becomes 2x, and the 4 goes out here. So here we go. We want to divide this in half. Negative 2 over 2 is negative 1, and you square that. Negative 1 squared is positive 1. So positive 1 goes right here. And remember, we need to, since we added that to the left-hand side, we need to counterbalance that. But it's not a 1, it's actually a 4. It's a positive 4, so I'm going to take 4 away. Let's move on to this one. We're going to cut that in half. 4 over 2 is 2, and 2 squared is 4. So I'm going to add 4 right here. It doesn't get multiplied by anything in front, so that's just another minus 4. And that was completing the square. Maybe I'll do a video just on that skill a little bit later down the line, but now we're going to want to FOIL this thing. We want x minus 1 quantity squared plus y plus 2 quantity squared. This is minus 12 minus 16. And let's get that 16 to the other side. So we have 4 quantity x minus 1 squared plus y minus 2 quantity squared equals 16. And just like in the last video, we're going to want to divide everything by 16. We want to make that equal to 1. So it's 4 over 16, which is 1 over 4. This is over 16, and this is 1. So from there, we have our, we have our equation. So we have the ability now to sort of extract A and B and C. A, B, and C. So remember, the A is the bigger of the two denominators. It's right here. That's actually A squared. So if 16 is A squared, A is 4. And B is 2 because this is B squared. C is going to be given by this equation. In an ellipse, that always works. So C squared is equal to 16 minus 4. C squared is equal to 12. So C is equal to square root of 12. Square root of 12 is 2 radical 3. And I did some radical simplification there. You can see that in some of my other videos, but what I'm basically doing is breaking 12 up into radical 4 and radical 3. The square root of 4 is 2. So there we go. There's our C value in its simplest terms. Okay, so we have A, B, and C. Let's talk about our major axis. Our major axis is, in this case, the bigger number, the A value, is underneath the Y, so our major axis is going to be vertical. It's going to be an ellipse that's sort of shaped like this, up and down. And I think we're ready to go. Oh, the center. Yeah, the center is probably the best place to start. The center is positive 1, negative 2. Positive 1 and negative 2, I'll put that in red. Positive 1, negative 2, right there. All right, from there, our major axis is up and down, and if A is 4, that's kind of the distance from the center to the vertex. 1, 2, 3, 4. Down. I'll put it in a different color. I'll put it in green. 1, 2, 3, 4. Down. 1, 2, 3, and 4. So those are our vertices. In green we have the vertices. And B will tell us the location of our co-vertices. B is half the length of the minor axis. So we're going to go 2 to the right and 1, 2 to the left. Those are our co-vertices. And the next thing we want to figure out is the location of each focus. And we're going to do that by looking at the C value. I'll bring it up there a little bit. The focus is 2 radical 3 units away from the center. 2 radical 3 is about 3.5 or so, if I'm not mistaken. So it's approximately 3.5, something like that. And that is going to be, the foci are always on the major axis, so we're going to go 3.4 units up from the red and down from the red. So 1, 2, 3 and a half, 1, 2, 3 and a half. Those are our foci in brown, and of course we're going to want to connect all these vertices together. Not too bad. Let me see if I can use my little trick here. And needs a little adjustment. Move it a little bit to the right. Not too bad. Maybe we can move it down a little bit too. But you get the point. All right, when you graph these things, they don't have to be super precise, but it helps to kind of get the general shape down. If you're not using a computer program, it's sometimes a little tricky. All right, so I guess it's probably a good idea to be really thorough here and kind of start making a list of not only where your center is, but also the location of your vertices, your co-vertices, and your foci. So let's make a list. We have our center. We said was at 1, negative 2. Our foci are at, let's see, our foci are at 1, and then we got to go up that many. But up that many is, you can list it a couple different ways. We're going to go 1 to the right, and then what I'm going to do is reference all this stuff in relation to my center. So my center is down 2, My foci is up 2 radical 3 from that. So it's down 2, up 2 radical 3 from that center. All right, and that is an exact value. All right, if you're getting into the habit of using decimals, I would probably recommend not using decimals, especially if you're in my class. I'm not going to really accept those decimals. I want you to get into the habit of using exact values. And the other foci is going to be, let's see, 1 to the right and starts at -2, which is the sort of the y coordinate of our center. And then we're going to go down an additional 2 radical 3. So it's -2 down 2 radical 3. So that's the location of our other foci. Our vertices are the endpoints of our major axis, and those are pretty simple. Those are in green, 1, 2 and 1, -6. Our co-vertices are in blue. Those are the endpoints of our minor axis, -1, -2 and 3, -2. And it might be a good idea for me to go back up here to this example and kind of write down those exact values for you. So let me do that now. Let me get this out of the way. And we'll write down our center. That's -3, +1. Our foci are at, let's see, negative. All right, so this is kind of cool. We're gonna go. They're definitely up 1. The foci are, remember, in purple. They're up 1, but if you remember, it's the C value away from our center. So we're in the x direction now. So the center is at -3, and we're going to go an additional C value to the left. The C value was radical 3, so it's -3 minus radical 3, and then up 1. The other foci is -3, and then we're going to go backwards radical 3. So it's -3 plus radical 3. It's kind of a funny way of writing that, but it's the exact value. The vertices in example 3 were in green. I think those are pretty simple. -5, 1, and -1, 1. The co-vertices were the endpoints of the minor axis, -3, 2, and -3, 0. Cool. Alright, so that takes care of 3 and 4, completing the square, and tons of graphing, vertices, foci, center, all that stuff. Brief little discussion on eccentricity. You might hear in my class, I might talk about eccentricity a little bit. And eccentricity is basically just how sort of ovally an ellipse is. And that's kind of a funny way of, it's a funny adjective, it's probably not even a word, but the eccentricity measures the ovalness of an ellipse. In other words, how squished is it, how stretched out is it, how close is it to a circle. You can see this eccentricity right here is very close to 0, and the ellipse looks a lot like a circle, whereas this eccentricity is very close to 1 because the ellipse is very ovally. If the ellipse is very circular, then your E value is close to 0. If the ellipse is very ovally, you know, maybe it looks like this, then your E value is close to 1. And to get that E value, you just take the C value divided by the A value. And it's also probably worth noting that you can find the area of these ellipses using a really easy little equation. The formula for the area of an ellipse is take pi times the A value times the B value. So it's kind of useful. Alright, now it's time for you to try some on your own. So here's what I want you to do. I have 4 problems for you. Each one asks you to be very thorough and graph write the equation, identify all the missing points, the vertices, the co-vertices, the foci, the center, and graph them, all that stuff. First three are pretty straightforward. Number 4 is a little bit of a challenge because it has a lot of fractions in it, but at this point, pause this and go through each one of these, see if you can come up with all of the missing pieces. And I'm going to actually present to you all the answers in a second, but remember, one of the best ways to check some of this stuff is to use this website, desmos.com, and that's like a nice online graphing calculator. And the other one that I really recommend is wolframalpha.com. It's a really awesome computational search engine. It'll give you all sorts of really cool stuff. You can check your work using that, but go ahead and pause this, and then when you're ready to go, press play and I'll give you the answers. So here we go. Number one, the foci are given and the major axis is given. This one's very, very close to a circle. I graphed it for you, including all the coordinates and stuff. So go ahead and check that. Pause this. This E value is very close to 0. Number two. Number 2 is next. Again, hopefully you tried this on your own. I'm not going to show you how to do this problem, but these are the exact values. This is the equation, the center, the foci, the vertices, co-vertices. Go ahead and pause this, check your work, write this down. If you have any questions, you can just, make sure you can just comment on this video and I'll get back to you. Number 3. Equation, center, foci, vertices, co-vertices, as well as the A, B, and C values. Pause it, check it. This one required some completing the square. Any questions, just comment and I'll get back to you. And finally, number 4. Number 4, we have a little bit of a challenge because notice the equation has fractions in it. So that makes things a little bit more difficult, but I enjoyed the challenge. Your A value and your C value have roots in them, and you can see a lot of the points down here are really kind of crazy. A lot of fractions, a lot of roots. So there you go. There's part 2 of our 3-part ellipse series. Hopefully you got a lot out of those examples, and hopefully you tried those exercises on your own. And if you have any questions, just shoot me a comment and I'd be happy to help out. In the next video, we'll get some more practice and kind of wrap this up. So thanks for watching.